think we are back. I don't know. Yeah, Eric. Okay, which way do I turn? That way? Yeah, right. Yeah. I think we're just going to start because everybody's at lunch. And I think, is this also recorded? Yeah. Okay, well, hello.
So you want to honor the on-timers?
Honor the... Where is it? Okay. Okay, good afternoon. I'm going to talk about the programmable RegTech ecosystem. And I've done quite a lot of looking into what that is, but I also work for a company that serves over 70% of Fortune 500 in the United States. When we started the company, everybody said, you are so going to fail. Nobody's going to put pre-financial data into the cloud. But the pain point that they were going through, which I will explain a little bit in my presentation, was so painful that they really threw up their arms and said, there's got to be a better way. So with that, we're going to talk a little bit about the empowering the digital transformation. We're going to talk about the elephant in the room. RegTech, what does it really mean? Because I think that it's still not defined in a way that the market and everybody can understand and say, okay, that's RegTech. Because somebody will come up and say, is that FinTech? And then yesterday, Eric and I announced Audit Tech. So there is a lot of different angles to this. We're going to talk about the RegTech data lifecycle, what they do to get the reports together, and then what's next. So empowering the transformation, and I look at that. Don Tapscott came and spoke with us at one of the XBRL conferences a long time ago. And he really emphasized one thing, and remember this is 2006 when he wrote this book, but mass collaboration is going to change everything. If there was no mass collaboration, XBRL wouldn't be here today because Eric could not do it alone at home. It needed a market participation. So how did we get there? Well, does anybody know that it was 1703 that we actually came up with the 1 and 2 kind of a theory? And here I get to brag a little bit because the computer was actually invented at Iowa State University. Yoo-hoo! Can I get a little cheering from the crowd? Good. And guess where we are? We are in Ames, Iowa. And then, of course, Tim Berners-Lee came on the scene and developed the internet or the protocol and so on. But if we look at how quick, as far as growth, there is actually almost 7.5 billion people on the internet today. That's quite a lot of people. I remember searching XBRL 20 years ago, and there was 3 hits, and 2 of them were Eric, and 1 was Charlie, and then mine was IMA's thing, so 4. Internet users are over 3.7, but if you start looking at the growth that it's happening, this global digital snapshot is updated every quarter, and it's very good, accurate information. So when you start looking for annual growth, it grows at 10%. Activity of social media. I mean, I've been posting on Facebook and Twitter and everything since I walked in the room here. Unique mobile. Many parts of the world, they only have mobiles. They don't even have the real internet. So this was just to set the stage. But the truth of the matter is, it's all about the data. We need smart, discoverable, consumable data, or it's meaningless, because big data has just gotten too big. So let's talk about data quality. I can just see this scene in the corporate compliance meeting. I spend a third of my time tracking and analyzing regulatory changes. I'm experienced regulatory fatigue. And as more and more has become personal, we are actually making accountability to individuals. We can no longer hide behind the organization. We also now carry personal liability. Because when the financial crisis and all that stuff happened, thank God they got Martha Stewart. She made $20,000, but all the bankers are still free. Okay, the cost of data quality is staggering. Companies are struggling to be able to, and this is a US statistic, But the fact that it's costing over $611 billion, according to Gartner, because of poor quality data, it is enough to get CEOs to listen. If that is truly a major cost to the organization, how do we go on? Here's some statistic for you. If you've never been to Mercator Center, they're doing lots of research on cost of compliance, and there's a lot of good papers there. But since 2008, they say that US regulation would be the 4th largest economy in the world on the cost if it was measured. So, where are the problems? We did a survey recently, and we came back with the top issues that the compliance directors have. 65% of them still live in Excel hell. And how many of you have trusted the data that sit in those silos all over the place? Can't make any changes with IT. Sometimes I feel like the IT people want it that way because they want us to call them. Or spending too much time on data cleaning and manipulation. Spending too much time badly fragmented system, unable to agree and accommodate change in information. This report is free, so you can go and get that on the web. But here, I've been involved with the World Economic Forum for several years and released a book there called Trust Meltdown a few years ago. But this paper in 2015, has anybody read it? The Deep Shift? You should read it, but basically what it states is, we stand on the brink of a technology revolution that will fundamentally alter the way we live, work, relate to one another in a scale, scope, and complexity. The transformation will be unlike anything human has ever experienced. They have about 12 criteria in there that they talk about the impact on the future. So truly, even if we sit here thinking about all of the things that needs to be in place to be able to reach these goals, goes back to collaboration, standardization, and we need good quality data. So the programmable RegTech ecosystem, I've kind of been starting to look at this for the last 5 years is, what infrastructure do we need and what kind of challenges do we have to overcome to have really a programmable ecosystem? And I pick on the regulators. They still think, or audit standard setters, they come up with a standard and they give us 700 pages of PDF. Yeah, that's really the 21st century, huh? We need data that we can take into application and innovate. So as long as you live in the PDF world, you're just not going to help. You need to be part of the solution, not part of the problem. So what is it? Well, it's just the use of technology, but when you start talking to people, you get all kinds of definitions like, is automating rules and validation RegTech? So I think that, and Mikael and a couple of us are starting a paper on RegTech here with the World Bank and hopefully Eurofilings to kind of define a little bit more about what RegTech is. So still, as I say, an ecosystem that nobody can say. If I asked Tom here what RegTech is, you probably tell me one story, and then I'm going to go over to Ignacio because he's not paying attention and ask him, and he's going to tell me a different story. So I think the definition of RegTech is still evolving. So with that, let's stop talking about big data. Let's just talk about all data. We can't just think about doing audit the old-fashioned way with sampling and go in and shoot the wounded at the end of the year when transactions are truly growing. I mean, look at Walmart. They do 4 billion transactions a day. So I'm going to put this ecosystem here for you where we need to start thinking about it. And I'm not telling you I have all the answers, but I took UK as an example. Because one of the things that is the biggest challenge for anybody who produces regulatory report is when the CFO or somebody comes in and says, make a change before you file. The legal said it. Do you know what they have to do unless they have this in a unique digital way? And I'll talk about what that is in a second. They have to spend the whole weekend and Monday and Tuesday trying to figure out, because when one number changes, It changes many parts of the report. Graphs, charts. Not only that, but they got to report that same number to board of directors, to management. And so they have inconsistency of data at all time. So we need to get to this model of one true source for the data with multiple views of the data. So when you change it at the source, you know that the board book is at the same level, the presentation, the press release that goes out. So we have to get into what we call suts and muts. Have you ever heard about suts and muts? Single source of truth to multiple view of the truth. And we as a company, we live smuts and muts. That's how we think. How can we get that one truth of the data to multiple view so that when Ignacio comes in and tells me that I have to change the number at the last minute, I go click change, no matter if it's in a graph, if it's in Word, etc. So this kind of environment with one truth to the data, smuts and muts. You learned something here today. So by doing that, you have a whole system. Some of the data, because of the great work of the Eurofiling coming up with a data point model, there isn't a lot of collaborations and things like that. The validation rule sits within the system, and they report directly to regulators, but they also report statistic information. Then they go down and they have to follow ESMA rules, and then they file with the company house, and then they have to do HMR filing, and then look at all these others. There's a major effort right now in the UK, for example, that by 2020, they're going to have a chart of account for natural capital. The reason for that is they believe that GDP only measures income and not the true underlying asset of a company. So some of us in the room here are actually writing that document for the UK government on how to integrate XBRL into natural capital. As soon as I looked under the hood, it's like the old days of IFRS. What they did, there are over 40 ways to calculate natural capital for one specific capital because nobody could agree. So we're going through, in fact, in the next couple of months, we're going to release a statement between the World Bank, IMF, UN, and some other key players, including XBRL, that we're going to come together as a group to harmonize, because right now, companies has to report statistic natural capital to the Statistical Bureau, over there, ONS in this case, and then they report it in their annual report, but most important, they're managing their companies like that. One of the major software drink maker almost had to shut down because the city where they had their water plant to feed the factory to create sugary Coca-Colas or Pepsis or whatever, not telling you which one, they almost had to close down because the city was going to shut them off because they had taken too much water from town. So these natural capitals are becoming huge risks on the balance sheets, and investors are asking for more information. So UK is driving it. But my point is, you can see, unless you think smuts and muts, you are not going to be able to meet the demands. There has to be a collaborative effort to be able to have one truth for the data to multiple users. So I started to look a little bit at the model. I'm not saying this is a perfect model, but it kind of simplified things for a simple Norwegian. So at the bottom, if you look, we had a shared ledger before. There were databases, but now we're going to have distributed ledger or with the blockchain. Later on, we're going to have smart contract. Was the middleware. Now we're going to have business rules. Well, first of all, we talk a little bit about smart contracts, but smart contracts are really only as smart as a programmer, okay? So that goes back to that trust issue. If I can't understand the underlying, if the data is quality, it's not going to be good. And then we have now new interface application, but we have bitcoins and other coins. And then machine readable data. We are moving away from documents, which goes back to any time you start thinking about producing a document, is there a better way of doing that? Not only that, technology today, for example, if you're working on your annual report I want to share it with Mikael, but I don't want him to see the net income because he's going to sneak out and trade before it's released to the market. I can now also section out that he can only see certain things. Fill in your footnote on pension, stay away from net income. So you have more controls around section, module, agile way of producing document with an audit trail. And many said, it's only 6 years, a little over 6 years since we were founded, that nobody will put the data in the cloud. But that's changing even here in Europe. So today, RegTech data lifecycle. I'm going to quickly go through that and explain the process. So you have ERP system, you have Excel, email, PDF, screenshots, phone calls, all this kind of information. And then you kind of put that into some kind of format. It's a document, it's an Excel, to transfer that information. And then you got to make rounding and adjustment. Think about doing that for every number unless you have a smuts and a muts. So with that, you have large data sets, staging documents, etc. On top of that, you have context and analytical review. Imagine doing that in silos. Many different, especially as we move into integrated reporting. We are not even just thinking of financial data. Now we have data stored in many other places around the organization in silos. From there, you're then going to output that information to regulator, and key challenges. Good data governance. Remember, regulators don't even just look anymore at what you report out. They actually start telling you how to run your business by telling you which KPI to capture, etc. But the new audit rules, the enhanced audit report that's being mandated now, both here and in America, not that America and Europe can agree, because key audit matter with the K is the European way, and in America we call it CAM, critical audit matters. But it has the same effect. For the first time, auditors who audited all those bankrupt companies, and they keep auditing again, now they're going to actually have to disclose key audit matter. Another report that will be in there is the audit committee of the company will also have to disclose their approach to auditing and how they discarded their duties. So in my opinion, if you don't think good data governance today, I don't even think, you're going to be the dinosaurs. Where's Eric's t-shirt? The dinosaur? We need to get some of them. But you have to get to that level of good data governance. The time to report is also being shortened. Even if you don't report the information out, you just need it to management, we need more timely information, and we need all the departments to make the same, not the same decision, but have the same data and make the same decisions on the consistent data. It's a very excessive manual effort, lack of time for review. We get a lot of complaints from companies that says, we don't have enough time to review. We got all the data, report is there, but we don't have time to review. So inside application, we need more innovation, insight to verify information, etc. Collaboration. Nobody creates document alone anymore. If you send me an attachment and say, please review that, I just go, please find a place in the cloud where we can collaborate. How many times do you get an email and then they say, oh, no, that wasn't the last one. You're supposed to make comment on that, and you had already sent your comment in on the other one. This kind of version control, those days are gone. So if you still live in that world, you are really making it more difficult. Duplicated processes, version control. But if you have suts and muts, you can actually single source, oops, I spelled that wrong, SS, so, to multiple view, you in the cloud can make all of these changes, have all of the controls, audit the trail for anybody that changed it, not just on the document, but if they changed the number, you can go back. You can also collect all of the data so it rolls up. So suts and muts. When you leave here today, there's a great article in last month, Harvard Business Review, that actually is the first one I've seen in the marketplace. We know, talking about smuts and muts. So I'm not the only one, even Harvard is talking smuts and muts. Okay, so what's next? First of all, we got to start thinking about, so we got the collaboration down, we got the data into the cloud, we have good data governance around our processes, etc. But now we need to innovate. And I say the next phase will be the, and I can't say it, I'm from Norway, some of you Spanish people in here is probably not going to say it either, right? But logarithms, did I say it right? I know, Eric, you speak my language, you translate.
English is my second language, I don't have a first.
But that's an American claim. You know, they don't speak more than one language. Anyhow, yeah, you didn't get any comment. The logarithm RegTech ecosystem, there's going to be more intelligence. We're going to have to get smarter in putting similar processes, artificial intelligence. So what we spend a lot of our time is, how can we help validate rules? How can we make sure that the data is correct in the smuts and the muts? We are looking at how do you create intelligence? And really, the future of the economies are going to be around logarithms and intelligent people that can produce them. So my key message to everybody in this room, due to the fact that we have short time here, is that the programmable RegTech economy ecosystem will take mass collaboration. We are going to have the regulators at the tables. We're going to have to need their leadership. And when you look at the leadership that we see at the Bank of England, I love it. But we need more of the regulators to step up. And I know there are other countries leading it as well, but we need them at the table. We need the software vendor. We need Fujitsu. We need Workiva. And you. Come, we need you too. Yeah, come to you in. It's mass collaboration. We do need to collaborate. The leadership that Eurofiling has done by getting all of these banks together, I get goosebumps when I think what they've done, just as few people. So we need to collaborate more. We also have the issue of standardizing taxonomies and having good data quality. We had a great discussion. In fact, Mikael, that was the best ever, the 2.5 hours we had yesterday. I absolutely loved it. And can't wait to work more on that. So with that, I want to say thank you. I just really enjoyed these last 2 days, and I want to thank the organizer for this. I even put hearts up there. I love you. Thank you very much, and let's do it again next year. So key thing, smuts and muts, you all get that? Single source of truth to multiple views, source of views. So, smuts and muts, here we are. Who's next? Who should I?
To the gentleman who's coming up.
I got you. You can put it on your nose.
You all know Leaf, so I don't think it makes any sense to introduce her anyhow. She's been everywhere from the beginning of times, and she's responsible for more things than I can imagine in terms of these changes. And a fantastic person. Next speaker, Henning Dietrich. I've had the pleasure to start working with Henning on a quite recent project a few months ago. And I have to say that I'm a stubborn person, and I sometimes take a particular perception on something, I read a paper, I disagree with that, and so on. And I have to admit that this is a gentleman who's been able, during this conference, to convince me that I was wrong about a particular paper perception. I'll not mention the paper, but what it takes is actually a rational argument, a lot of knowledge, and a very good way of explaining it. And I'm really looking forward to this session where Henning will tackle some of the very advanced technological concepts related to the blockchain. Related, if I remember correctly, you mentioned irreversibility, right? The reversibility. I'll not try to understand it yet. I'll just leave the space open for you. Floor is yours.
Hello. All right. Thanks a lot. All right. Do we have a clicker or something? Cool, thanks. sorry, this will need a USB stick too. So these. Yes.
Here at the front of the desk.
This one?
Yeah, this one.
All right, cool. Yeah, that works. All right, so this is going to be technical also, but on a very high level, with the hopes that everybody's going to be able to benefit from that. First of all, who here in the room is actually working with blockchains? Who's confronted with blockchains from time to time as part of the RegTech discussion floating around? Okay, that's clearly the majority. Who here is technical in the sense of being a programmer or system architect? Okay, so we have a good half and half maybe. So first a word about, okay, this is not really happening yet. Sorry, this is just picking up the clicker. It might work now, yeah. Oh. Just worked. Okay, cool. Okay. Thank you. Sorry for that. So, the topic of the talk is actually one of the challenges that we see in the blockchain space right now. You will all have heard about the irreversibility of blockchains, and this is actually a feature of blockchains. Although for many practical applications of it, you would sometimes wish it was otherwise. I'm going to be discussing technical aspects, why that is so deep in the fabric of blockchains, but also how this can be overcome. Some words about me. I met Mikhail working for the European Commission for a project where I think we have a great complementary application there of the different things we bring to the table to create something really new for the European Commission. I've also worked at IBM. I was actually the architect, the first architect of the IBM blockchain Hyperledger. A long time ago, I had the pleasure to create a language for the insurance industry, something that was not just a hobby horse, but what we found was necessary to actually be able to express certain generic things you wanted to have for a front end for insurances. But that is something that is very similar to what we see in blockchains, which are actually also having a virtual machine, as it's called, because every transaction already with Bitcoin is actually a small program. I did a lot of functional programming, big data. I wrote a book about Ethereum that is also a very high level, not technical work that tries to give people who are domain experts the chance to start to bring their expertise into the blockchain space, because I believe that's super important so that there's not some inventions happening in the vacuum, as we see in many startups in the blockchain space that don't have a good domain grasp. I am going to present a little bit about the irreversibility that is native to blockchain, so to say, then the problems that arise from that, obviously, and then we go into one of these basic building blocks of how blockchain actually works and look at how this could be extended to create reversibility. Reorganizations are something that is a bane of the blockchain world, and that makes it very hard for programming applications on the blockchain. Reorganizations are actually what happens when blockchains lose this kind of very steady, very mechanic flow of creating one proof of the truth after the next. And it's something that is a compromise, so to say, where the consensus protocol that is allowing a blockchain to have thousands of nodes that all come to the same conclusion breaks for a little moment and reorganizes itself. This is something that is, in a way, similar to what we're going to be discussing. It's at the heart of where blockchains become, if you try to really program applications on top of them, a very, very difficult beast to tame. The basic premise of having blockchains being irreversible is something that's already in the Bitcoin paper. That is the reason given there by the mystique inventor of Bitcoin is that this is going to cut overhead. The explicit text that he's writing is that the irreversibility of blockchain is going to be exactly what is going to cut out the cost that comes in the banking system with being able to reverse transactions if something was found lacking about them. So that has been part of that's part of the very first paragraphs of this Bitcoin white paper, and it has been fundamental to how blockchains are constructed. On the other hand, the reality of blockchains is that they tend to lose state. Exactly during those times of reorganization, when the thousands of nodes are, for a moment, not in consensus about what is the actual truth in the system right now, you can have a situation where a node in the blockchain network tells you one truth in one moment. For example, a transaction has gone through, which would maybe make a merchant sending goods over to somebody who just paid him, to in the next moment stating that the transaction actually never happened. And this is something that's very rare, but it's also something that is absolutely not something that banks can work with. And considerations like that, for example, were very important when IBM considered how to approach the blockchain space and led to the development of the IBM blockchain. So if we're talking about blockchains for regulation, about RegTech, we have a very strong challenge there, and that is that courts can in fact change history. They can go back, they can create a fiction, and they can say, well, actually, this company was bankrupt since that point in time, or actually, this contract actually never happened because something was wrong from inception. And what happens if a court finds that a certain contract, for example, should never have happened is that if a smart contract runs on the blockchain, and for the benefit of making it simple, we'll just assume smart contract here is something not quite like a contract always, but something that is an agreement that then in the end shifts, for example, cryptographic assets. Then if that shift of possession has happened, and it can also not be stopped on the blockchain because that's one of the great elements that blockchains bring to the table, what they can create is a split between ownership and possession. And a court can basically assign ownership in a way whatever it seems is the right outcome, while a smart contract is usually not flexible to just change that. And this is at the heart of the problem where irreversibility leads to the point where corporations can probably not afford to go with blockchains as they are right now on a big scale, because if something happens, something goes wrong, they open themselves up to class action suits, where if blockchain was, for example, used to govern IoT devices, all of a sudden everything they do has to be organized because a court says so. And then with the blockchain, you have a great problem. On the other hand, if we talk about reporting, and this is actually one of the points where how I arrived at what I'm going to show here, if we talk about reporting, likewise, there has to be a way to make up for errors. There has to be a way to adjust the actual data to what a court might decide, even retroactively. So the solution to this, that I honestly believe is going to be implemented in the deeper fabrics of the blockchains we are going to use in the future, is twofold. On the one hand, there is going to be an arbitration window, I believe, that is very similar in what happened in the DAO debacle that happened on the Ethereum blockchain. Who here heard about the DAO? Okay, so Ethereum had this big learning as a community of having a very prominent project in the Ethereum space, the DAO, called the DAO. DAO stands for Decentralized Autonomous Organization. That was basically an investment fund. That was basically set up by some people who hoped to maybe raise $500,000 for their company. But what happened was actually that $150 million were paid into this investment fund, and then a hacker found a way to hack it. And $50 million were sucked out of it, basically, in broad daylight. It was like, I was sitting at my computer, and then all of a sudden in the chats, there was something like, oh, I believe the DAO was hacked. And then, because blockchains work as they work, it's out in the open, right? You can see every single transaction. So over the course of hours, you could see that money drained out of that fund. And nobody could really do anything about it. Until the founder of Ethereum basically made a call to the exchanges to please not exchange Ether for a time, so the theft could not be reverted into cash. But actually, what kind of saved the day was that the way those hackers could attack that DAO, which is a smart contract basically on the blockchain, was by cloning it in the instance, that was just so, and then diverting the money from the original DAO into that clone. That was just a specific element of this attack. And that clone had, like the original DAO, a certain limitation that only after 27 days, the money could actually be paid out. That was a security mechanism, and it actually helped saving the day, because then the Ethereum community came together, and what they did was actually they went back to the social consensus, which has always been postulated by Vitalik, the inventor of Ethereum, as the actual backstop, and said, okay, we are going to do the thing that should never happen on a blockchain. We are going to rewrite history of the blockchain. Because they had 27 days, they could actually do that. They programmed, they sat down, they created programs that actually changed the history in all the clients of the entire network. And of course, there was a heated debate behind the scenes about whether that should actually ever be done, or whether the hack was actually really a failure of Ethereum, or rather something that should be left alone because the hackers had just found a way to use the program differently. But it was not really Ethereum crashing or having a flaw. It was just a flaw in the DAO program. Now, this shows the way forward, though, I think, because this arbitration went in this window that was left open, this 27 days, is something that we know also from how credit cards, for example, work. And that is not coincidentally so. So this is one element that should probably be introduced in the deep fabric of blockchains, to be able to quarantine contracts if you want them, or if you want that, or it's important, and to be able to do something about if something goes wrong. The other is state layers.
Did they ever go to jail, the people that did that? Did they ever discover who it was?
No, they didn't. They probably never will.
Probably never will.
No. I mean, blockchains really are designed in a way to have an identity system that is all about giving you authority to do something. And it's completely different than the identity system that we are usually talking about, where it's all about finding out who did something, and then putting that person to jail.
I was just looking at it from an auditing standpoint, right? How do you audit the blockchain?
Well, it was also not easy for those guys to get the money out. They did probably get some money out. That's a longer story, because basically this whole exercise led to the Ethereum community to split. And in the end, there was a new Ethereum that had gone the way of this correction that the community decided they wanted to make, but some remained behind. And the interesting thing is that even Vitalik could not make everybody switch away from the old version of Ethereum, where the theft had happened, to the new version of Ethereum, where the theft never happened because they changed the software. It's a very exciting topic, but
isn't it just another time before they hacked the second one?
It was a big learning, and it came at the right point for the community as a whole. And all the attacks that do happen, especially last year, we had a lot of attacks on Ethereum, are making the system harder, because people work hard to create the solutions for that technically. And I keep saying that Ethereum is out there and it really works, like Bitcoin, like Ripple. There are a lot of projects, but nobody really knows whether they will ever really see the light of day. But those attacks are, of course, helping those systems to make them harder. So state layers are something that we also know the internet itself has layers, the Darpa layers. it was conceived like that. It's all about this philosophy of making a reliable system out of unreliable nodes. And this whole packet switching mechanism that was invented to make it safe in a time of a nuclear war crisis is basically exactly this. It's creating layers where you can do different things, you can assume different things depending on what perspective, what layer of abstraction you're working in. And this is probably what we will also need to make blockchains reversible. I would like to mention that I'm giving more details about how this actually should work. I'm going to focus on one thing here. It's part of a paper I'm working on, and this is actually about a different aspect that I find also very important. It's about making smart contracts readable. So I'm positing a smart contract could actually look like this, written in a very human-readable language instead of how smart contracts work right now. And that is complementary to what I'm presenting here right now, but you'll find more details about it in that paper, and it's not published yet, but I'm happy to give anybody who's interested a copy and be very happy to get feedback. So now we're going to deep dive into some crypto magic. And the main benefit will be for people who actually do not yet really dabble in blockchains too deeply or are not technical. Those who are more technical, I'll be asking for some patience while we go through this, but in the end, hopefully it all come together and make sense. So I was actually planning to live program here, but I wasn't quite sure if that's going to be possible with the Beaver and everything, so I put this on slides now. But what I'm going to show here right now is pretty much what you would type in a terminal. If you were a programmer, you would see me typing exactly this. And I could create a bash, as it's called, where you can do live programming. And I could use this command to write the word hello into a file. And then I have a file on my hard disk, and there's hello in there, right? And I could use another command called show file, and then it would show me hello, because that's in the file. If I want to encrypt a file, and I found that it's actually beneficial for non-technical people to see, if I want to encrypt a file, I could issue this command, encrypt file. And then I would have to enter a password. And if I show the file then, it looks like this. So the hello is gone, and now something else is in there. If I want to decrypt that, I issue another command. It's called decrypt file. Then I have to enter the password again. And in my file, I have hello again. This is called symmetric encryption, and it's basically a way where I have to have shared secrets. Both sides that want to communicate using this encryption method need to know the password. They have to exchange the password. This is the basic thing that we all think about probably if we hear encryption. It's not actually, though, what is used a lot in blockchains. One thing that is used a lot in blockchains is called hashes. And that's actually so usual for programmers to use, we don't really think of it as magic, but it's a very important building block. And what a hash is basically it's like a cross sum. It's a lossy function where you can take a huge amount of data, put it through a function, and then what you get out of it is a certain number of, very small number of bytes. Could be like 32 bytes. And 32 bytes actually is still a huge number. If you would write that out, it's gazillions of zeros and whatever. It's a number, it's so huge. If you would just randomly pick a number, if everyone would just randomly pick the number, the world over, the whole globe would do that exercise. There's no way that anybody would ever have the same number twice. And that's the basic functionality of a hash, where you could have huge amounts of data, and we send that through a good hash function. Bad hash functions do sometimes have the same result twice, but those are not good, and those are sorted out. If you send those gigabytes of data through a good hash function, you will never get the same number in the end. And this number in the end, this hash, is then a unique identifier, a pseudo-unique identifier for this big blob of data on the other side. And that's super important, and this is an element of hashes that's used a lot in blockchains. Because you can have, by that, a number of whatever it is, 32 bytes, for example, that is something you can show around, and you could show anybody. And they will never be able also to guess from that 32 bytes what that big input was that you actually put in. But once you show them the input, they can verify themselves that this is actually what you showed them first, that this hash belongs to this. And now you can see immediately how in reporting, this can be used for somebody could create a huge report and then hash that. So there's 32 bytes. And they could actually show that to the auditor preliminary and say, okay, so yeah, I have this report here. I have this data here. Take this 32 bytes so I don't have to ship it over, because if you don't really want to do an audit, right, you don't actually need that data. But at any later time, the auditor can come back and say, hey, you give me this data at this certain point, right? You give me this hash at this certain point. Could I now please see the data? And there's no way that any bit in that data could be changed then after the fact by the company or the financial institution that reported without it becoming async with that hash. You would immediately know, is that really the data you committed to at the point when you sent that hash over? And how that looks, if I, for example, as a practical example now, I have my file again, there's hello in there, and now I'm hashing it, and then this comes out. If I put something else in there, I'm changing the E to an A now to make it hallo, German for hello, and if I hash that, a totally different number comes out. And that's super important. That's a very important aspect. Like, and even if I had more than just this one word, hello, to hash, but had like chunks of Excel files or PDFs or whatever it is, if I change only one little letter, a completely different hash results out of that. And this is something that is used all over in blockchains. And that is actually what is chained in the blockchain, because what blockchains do is they always take a block of transactions, and then they create a hash from that, and then they take that hash and put it in the next block of transactions too. So whatever you have in a blockchain is always having a chunk of data and the hash of everything that came before. And this is how blockchains actually make sure that whenever you have this last block, you cannot change any of the blocks before either, because then the resulting hash, the root hash as it's called on a blockchain, wouldn't be the same again. So it's all this huge mechanism to make sure no single bit of data has been changed. Another aspect that's used very much in blockchain, and there's fear that quantum computers might one day break it, is public-private key pairs. And they work differently. They can also be used for sending data back and forth. If you are accessing a server, for example, that had HTTPS in the URL, this is what's actually used behind the scenes between your browser and the server. The browser and the server actually create a communication with each other that cannot be seen by other people, cannot be decrypted by other people by using this public and private key pairs. This is different than what I had shown earlier with symmetric encryption, although that's also part of it, but the browser and the server do not have a possibility to exchange a password. Because anybody listening on the traffic would see that password too. So they have to use a different type of encryption to initiate their communication. And how that works is there are two keys, as they're called, and they belong together, and they have specific attributes. For example, the public key, as it's called, it's the one of the keys, can be used by anybody to encrypt information that can then only be decrypted by the person who has the private key. The benefit is, if the browser has a private and a public key, it can give the public key to the server. The server can use that to encrypt whatever it wants to encrypt and send that over again to the browser. And nobody on the way can decrypt it, only the browser, because the browser has the private key. So again, the public key is given out to the public. Anybody can see it and use it to encrypt data that can only be decrypted then by the holder of the private key. And obviously the private key is to be held private. But what's more interesting for blockchains is that they can also be used to create digital signatures. And again, if I would be live programming here, this is what you would see. I would create a private public key pair. This is the computer works for a bit. It takes a moment to actually create those. And if I look at how this private key looks, well, it just looks like this. Just an enormous amount of jumbled data. It goes on like this for a couple of lines. And we all know like 4 digits are even enough to secure a bank card, right? Or 5 digits, 4 or 5 or 6 digits to secure your smartphone. So you can imagine that something as much of jumbled data like lines and lines of this can never be guessed by anybody. And that is, again and again, the foundation of the crypto that's used in blockchains. If I look at how the public key looks, well, it looks pretty much the same. It's different, it's a little shorter, but it's in essence the same underlying principle. So just to show you real quick again to make it a little more tangible how that looks. So if I write hello in my file again, not hello, but hello, and I show what's in the file, yeah, it's hello in the file, then I can sign it. And I would type in, sign that, and then what I get is something like this. Now this is a signature that has been created over hello, because that's what's in our file, using the private key I just created, that was this jumbled lines of data. Now I again have these cryptic looking stuff here. And the important thing about this is if I give that to somebody, then they can use the public key and verify that only I could have created these numbers to sign hello. So that's important. It's these numbers, if I give that to somebody else, they can verify that nobody could have come up with this string of letters except me, who has the private key to that public key that they use to verify that. How that looks practical is that if I now go and type in a more complicated command here, which can look like this, I take the public key, I take the signature file, those just jumbled numbers and letters, I can mesh them together and check whether it actually verifies that it's fitting together and it's making sense. Yeah, this signs this hello with that private key. This is used in blockchains all over. This is actually what gives this authority that I was just mentioning to the individual account holder, that they can make transactions on the blockchain that send money around, crypto money around, and that somebody else then owns it. Because that's how it works on a blockchain. You always just sign off that you give away the money to somebody else, and then they have it. And this mechanism is used for that. Whenever you do that, you're signing off a transaction to somebody else. If I now write hello in that file again, so I change this one letter, the verification fails. Now, this is important. And there's a very easy last element to this whole thing. This is determinism. Determinism just means if I tell the computer to add 2 and 2, it will tell me 4. If I ask them that again and again, it will always tell me the same thing. And if you mix all these things together, you can create something that is basically an implicit signature, where you sign the inputs, and the results of that, you don't have to sign. They're implicit by what you signed as an input. You can demonstrate that if you, for example, write 2 into a file called x. So x now contains 2. And I now have a little program that just adds 2 to whatever x is. Well, it will result in 4. If I now write 3 into x, well, obviously, I will get 5 as a result. I can write this into a program, obviously, right? So now my program is called x plus y. If I put 2 in x, put 3 in y, the result is 5. Now I can sign x and y. And I can also sign the program itself. And what I signed with that, basically, is 5. So that's how a blockchain works, really. You have input variables. In this case, it's 2 and 3. And then you have a program. That's the transactions or the smart contracts. And if you sign all of that, you implicitly sign the result. And this is what gives the blockchain this new element of trust. This is what you don't have in a database, because not all different elements in a database are signed off. And it's also slightly different how logic and data are working in a database. And this is how you cannot really change what's in the blockchain, because you would have to have the signature of the person that signed the X to be able to change it. Well, if you have it, okay, fine. But even then, you cannot necessarily change what the individual elements are that you have not signed. And in a blockchain, usually what comes together is if I transact money to you and then you transact money over to you, then this creates a whole chain of transactions and events and inputs where different people have signed off what they were able to govern. And that creates, in the end, the truth of the blockchain, which in a simple case, like with Bitcoin, basically just is who has what balance of Bitcoins. The process of verifying that it's all automated in a blockchain, of course, is just like, okay, I check, is X the same, is Y the same, is the program the same as I've been told? And this is actually what clients do, so-called Bitcoin clients, or blockchain clients, when they go through and validate the entire blockchain from its genesis block. And when they do that, they go block by block and do all the calculations, check all the verifications for all the signatures of all the input elements. And then in the end have something as a result that where only one result could have been there. And all the other clients must come to the same result if they do the same thing. And this is how blockchains basically come to a consensus. If I would change something like changing the X to 1,000 and then run the program again, well, yeah, now I get 1,003 as a result. But for X, now I get a verification failure, obviously. This signed order of transactions, this step 1, step 2, step 3, that's basically what transactions are in a blockchain. And what is actually the important part that is signed about a block in the blockchain is the order of the transactions. Because we do things in a different order. Sometimes, for example, if somebody wants to spend his cash twice on Bitcoin, then at some point when they don't have any more Bitcoins in their wallet, one transaction has to fail. And for Bitcoin, of course, from the beginning, it was very important to understand, okay, what is the actual order you want to make the transaction in? Because at some point, if you spend all your money, we have to know which transactions will fail first. And that has to be the same for all nodes that take part in the network. Now we come to reversibility. How can you, although this all has to be deterministic, this can never be changed, how can you go in and actually change something, which I hope I have made clear is going to be totally against the grain of all that we just found about how blockchains work. Now, basically what we'd want to do is say a judge decided, well, actually, X was always 7. It's a mistake that somebody entered. It was 2. Now what will we do? And I believe the very simple proposal that we will see in the future is using layers of state that basically result to the lower layer of blockchains being kept completely as they are. Because you cannot go in and create a reorganization. It's just creating chaos. It invalidates existing proofs of exactly the hard nature trust, of the nature of the trust that you want to achieve by using the blockchain in the first place. Otherwise, you could just go back and using databases. Now, the way that smart contracts work in the moment is that you have this chain of transactions, transaction after transaction, and yeah, they come in different blocks, but it's not even so important. In the end, it's just important you have one ordered set of transactions, one after the other, and that results in a certain truth at a certain point in time. And when a smart contract operates, it looks at the tip of that long chain of transactions, basically, and operates on whatever now is X or whatever now is Y or whatever other programs have resulted into. And I'm positing that what we will see is that we will have different layers of transactions, layers of state, where the underlying layer is going to stay exactly as it is now. But there's going to be a second layer, and in this graphic it's still completely like the first layer. They're completely in sync, they are the same, but the smart contract will look at that higher layer. And at some point, what can happen is that, for example, by court order, a transaction comes in that says, well, actually, X should have been 7 and not 2, and a long time ago, even before you executed that program, and the result back then was 5, but we want the program now to result into 10, because X should have been 7. What will happen then is that on the lower level, you will keep exactly the blockchain logic. One transaction comes after the next, and they are signed off by the public and private key logic that I explained earlier. But on that higher level that will be constructed on top of that, there will be an element of that transaction that says, well, actually, I belong after transaction 2. I belong between transaction 2 and 4, and I have to be the new transaction 3. And what smart contracts will look at then is the second layer that has been reorganized, that is the business logic layer, so to say, where the results that are actually coming out there are going to be, well, the result of that computation was actually 10, not 5, and go from there. Going back into the language of the examples that we looked at earlier, basically what's happening is, well, although the program has already been executed, we now decide X is actually 7, and that you please go back to step 2 and start again from there. And this is, so to say, the view that will be on the blockchain. There will be a new type of transaction, kind of arbitration transaction, that has the possibility to, on the business logic layer, go earlier, but in a completely deterministic way. Nothing about our step 1 to 4 will actually change, not on the blockchain layer, but on the business logic layer, it will just be inserted earlier. And that is, in as easy terms as I can, what I would say we will for certain see, because reversibility is incredibly important to make blockchains ready for business. We will have to find a way to adjust the truth of possession in the contracts that they can automatically and unstoppably produce to what a court has to say about ownership or about facts that had been inappropriately programmed into a smart contract. And who should be allowed to actually make these new arbitration transactions? Well, I think that might well be the courts themselves. And in the moment, if you look at a court website, it looks like this. So they have their address there, and that's important, and when they're open, when they have business time. And it could be as easy as in the future just having a certificate there. This means so the resolution is not high enough, but it's just the garbled string of numbers in full this time that I showed earlier. It's just a public key that a court would have to post there. And the court doesn't even have to be informed if somebody then decides to take that key, program it into the smart contract as arbitration key, and by this, give this court the power, if it ever has to be, to change that smart contract and add this kind of arbitration transactions that change the history, so to say, of that smart contract. And I'm dabbling a lot of this stuff, and I've been thinking of this quite a while. I think this is going to be how it's going to be. I think courts will actually publish keys, public keys, which also arbitration courts could do this. Anybody could be empowered to be the arbitrator over a specific smart contract by just using their public key that they publish somewhere, because that is the beauty of this crypto magic. They don't even have to know about it. But if you then go to them and say, please, we need arbitration, we need a decision here, the smart contract itself on the blockchain can be changed to what it should be by the owner of that public key, and not by those who have entered into the contract themselves, which is super important, which leaves this unstoppability as a basic premise for smart contracts intact. So in the end, this is really on the logical level what we want to achieve with reversibility on the blockchain. And that's what I'm ending on here. And if there's any questions, I think I might be able to take one. Please.
Thank you for this interesting and clear explanation. One question is, contract might be followed by another invocation of that contract or another contract that's dependent on it. If you interfere as an arbiter, the outcome of some of the state of this contract will change, right?
Yes, thank you. So Mark?
As a consequence, in all the dependencies
Right. So let me repeat the question. Mark is asking about the ripple effect that would actually happen if a smart contract is arbitrated this way, where other contracts might actually have dependent on that contract, and you would potentially see a rippling through the entire network if one contract was changed, where all the other contracts were also then being changed, which means like if I spend cryptocurrency here and then all of a sudden it has never been spent, then somebody else has never received it. Thanks for giving me the chance to go into that. Wait, please, let me just answer. So for one, what I just proposed would allow for going the hard way and create an automatic clawback mechanism. It would be in itself consistent, very much like what I mentioned in the beginning, a reorganization on the blockchain always is, ending with a consistent truth again that just leaves out some aspects as if they never happened. Very much like the community in Ethereum repaired the catastrophe of the DAO. And very much like the DAO had this 27-year grace period, 27-day grace period programmed in, and very much like credit card companies work with credit cards. What you want to do is to have in the fabric a mechanism that quarantines the smart contracts for the duration of the arbitration window. And any payouts that come from that smart contract can only happen after that period of time during which an arbitration key can be entered has actually expired. I would like to take that question over there real quick. Please. Yes, so thank you for the question. The question was, how much doubling do I have? Do I have this second layer across the entire blockchain? The short answer is yes. You would have that second layer, and this is actually the layer you actually deal in. This is the layer you actually work with. The first layer that we have underneath becomes rather invisible. Like in the internet, web designers only deal with the top layer. They don't really have to care about how the traffic in the internet works. Just if some super big website really wants to tweak their bandwidth use and their traffic, they would go a level deeper, and then they can do stuff there. But it's very unusual for a normal web designer to even care about that layer. And that would be how accountants would only be looking at that new secondary level, while the first level is basically going to be considered under the hood, something you would ideally not have to touch. With this, I would like to thank you very much. Thank you for having me. Thank you, Mikhail.
Thank you very much, Henning. Ladies and gentlemen, let's take around maybe 20 minutes, if you don't mind, break for coffee. When we come back, we will cut out on one part, which is basically a debate after the rapid fires, but Eric and Derek kindly agreed to incorporate all the feedback sessions into the rapid fire presentations. So we come back, we have the rapid fire presentations, and then we should be pretty much on time with the agenda, as I was told that we will have basically a few words from Javier or the Dean himself say a farewell for the conference. So if we can get back here 20 past, I would very much appreciate it. Thank you.
If you are a rapid fire speaker and you have not provided your presentation, or if you're using your computer, please give your presentation to the gentleman on the front, or please bring your computer up so we can get through this very efficiently. Rapid fire. Go ahead for rapid fire coffee.
Can I give you my presentation for the rest of the time?
Yeah, sure. Use any of the tips.
Thank you.
again, I'm not very technical, but I'm learning a lot. And now, Readable can say, some years in accounting and consulting are running this shop in Belarus that's going to be blockchain and SRL together. So the quickest thing that I have in mind is how do you account financially all those transactions? How do you define revenues and financial metrics from the companies that's completely on the blockchain? Because, you know, transaction is huge.
They actually, I mean, the blockchain has this. Okay, but the interface between how you use these numbers, and you also started with basic company, and then you went through software intelligence. That would still also have to be there, right? And you would have to have. Well, okay, so technically, really what happens? So all the wallet of this is very much you on the blockchain that is using yeah, you can. I'll take a short break, and then I'll be here for the rest of it.
Okay.
Okay? Not to. Yes. So blockchains are always cached into local databases to do analysis, to do any form of searches. Did I say something?
No, it's
So you do end up having a database, and on that database, and you then also analyze between those because you have financial reports. The thing is, the blockchain as a starting point allows you to choose approaches. So it has been changed over time. I run outside now, so you can.
no, the interrupt. You may have taken this as Can you join me for a smoke, sorry? Okay, cool. Second, I have got this one because I can just click on one. Identity?
Yeah,
So both will be present.
yeah, I'm going to first do the presentation and then I'm going to show the video.
Okay. Who are you representing?
I'm Daniel. Surprise.
Nowadays, you never know. Do you have the voice?
Yeah,
And then
has a lot of music. That's all?
And do you know the order of the speakers?
the order should be like this.
Yeah, every single one. Yes, sir.
Yeah, but it won't be for sure because the last speaker cannot speak last because his flight is closing. So he has to be somewhere there. Next.
I wanted to go as fast as possible because we didn't have lunch yet.
Yeah, if you want.
If we can go like second one, for example, or did I go first? Or?
Well, you are the second one.
Yeah,
So
that would be fine.
cool, yeah. And actually the guy can be third, and then this is actually YouTube record. No, this is Sam. Okay, so this is YouTube recording, so if you don't mind. Yeah, we'll make some recordings.
My name is Jaakko Jevert. I'm a Finnish. SME auditor. Practicing in my own audit firm. Today we are going to spend the next 7 minutes with the problem of verifying bits. The auditor is in a role of
I know it's very, very, very.
assuring data trust.
I don't know if you can see the USB, so it's more easy for you because yes, it's better because you never know what could happen with the Wi-Fi. It's quite stable, but you really never know what's going to happen. Okay.
Sure. Great.
It's too much doubt, but what we can avoid,
Yeah.
we must do.
Buenas tardes. Thank you for giving me the opportunity to participate in the conference for trusted open data ecosystems. My name is Jaakko Jevert. Takujärveltä.
Rapid fire?
Yeah, Henning gave me a presentation on that because a lot of people will come with their laptops and plug them in.
You got to go to the airport.
Yeah, I got it.
So I've got your second.
Yeah, so if I can go first, then will be
Second.
Second, okay. Second, the guys which were second wanted to be second, but they are also in the hurry. Third is like for me really tough because I have Daniel and the girl. Okay.
Originally first was going to be Marcel.
Okay. Marcel, talk with them. The reason probably was lunch, so Mike will let you know.
You should go, if you go Huelva, you will see programs folks are the first speakers?
Yeah, after Marcel. Yeah. Well, no, actually, Carol managed to be after Marcel, so yeah, they will be third. Because Carol is in a hurry to run out. Marcel, Carol, Daniel, and then I don't know.
Okay. Carol, Daniel, and then if no one else is begging them, do you have this email? Yeah, I would just want to do it in order. So then Simon, and what I'm going to ask is I'm going to ask the first four to come up.
Yeah.
We're going to introduce them to concept. They have 1 minute to work things out with you. I start them off. They have 8 minutes to do whatever they want. At the end of 8 minutes, I cut them off.
No matter what.
Nothing else. And then we start the next minute to work things out with you.
Yeah.
We start it up after the first four. Yeah. We'll have a brief break. We'll ask everybody what do you think? We'll say, who was your favorite, 1, 2, 3, 4. Then we'll ask the next group of 3 to come up. We'll go through the exact same thing. We'll ask people which of the 3 they like. Then we'll have a vote off between the 2. We'll see what time it is. So, people have been maneuvering.
Yes.
And so here's what's happening.
Okay.
People are telling us that they want to go. So Mark is going to go first. Daniel and Carol will go next. Okay. Because they both have to get airplanes. Then we'll have Simon come up. For them to come up. Okay. We'll do our 1-minute intro. 8 minutes, 1 minute, 8 minutes, 1 minute, 8 minutes. We'll have people vote who is their favorite. Then we'll say thank you to them. We'll have the other 3 come up just in this order. And we'll do the same thing. We'll thank them. We'll have some vote for the rest of the 3. Okay. So the one off over the 2. We'll see where we are for time if we want to discuss anything else. But we'll get through our rapid fire so everyone has a chance to speak.
I'll leave you because you're doing this very well. I leave you the coordination. Okay. And I'll pick in if I have something difficult. Better that one run because we don't have too much time.
So I'm just going to go ahead and start in 3 minutes, no matter what.
Yes. First one is not there yet, so Mark.
No who?
Mark Sell, he's not here.
Oh. Well,
the people of Madrid are calling Mark Sell to the floor, please.
You can go with the last of the 4, and if not, then
yes.
We can sit here and sing during his 8 minutes. Testing 1, 2, 3. Testing 1, 2, 3. If our first 4 presenters are in the room, Mark Sell, Daniel Diaz, Carol, and Simon Olsen. So Mark, Daniel, Simon, Carol. If our first 4 speakers are in the room, please come up to the front. Mark, if you are here, please begin to coordinate with our presentation manager. The rapid fire session will begin in 1 minute. The rapid fire session will begin in 1 minute.
We are close to starting the rapid fire session. Thank you.
Daniel Diaz is replaced by the beautiful lady standing there.
If the person replacing Daniel Diaz wants to come up on stage.
What is your name again? Ana Teresa? Maria Teresa. Maria Teresa.
Do you start with a presentation or video?
So you're going to be on our second stage, so you don't come up for this one. So right now we're looking for Mark, Maria, Simon, and Carol, our first 4 speakers. It is the bottom of the hour. Here's what we're going to be doing. Hi, my name is Eric Cohen. Most people know me as Eric E. Cohen. I say if you don't use the E, you don't get me. Today I'm going to be known as Eric N.M. Cohen. That stands for No Mercy. That's right, this is the rapid fire session. During our rapid fire session, we have a 1 minute setup. I see that my first speaker isn't here. We do want to make sure that everything's done. We're going to probably be starting with our second speaker. So Maria, I'm going to ask you to get ready to speak. Get ready to speak. You've coordinated, you're all ready to go? Oh, Daniel's going to go first?
Yeah.
Okay, Daniel's going to. So Daniel, get ready to speak. Here's what we do. We have 1 minute to set up. They work with our presenter, make sure they're ready to go. During that time, Derek and Eric, the mighty Derek and Eric show. Here's what we do. We do a little dancing. We do a little singing. We keep you entertained. A little bit of music. And then when it's time, we look at our clocks and we say, you have 8 minutes. Here's what they can do during that 8 minutes. They can dance. They can sing. They can tell you about themselves. They can do a little show. They can take questions. They can do anything they want in their 8 minutes to wow you, the audience. But we are going to give them a 5-minute warning. We're going to give them a 3-minute warning.
We have to say problem, solution, and how we're going to succeed. How do we have to pitch?
We want you to be entertained. We want you to have the energy here. We hope you keep going.
And why the team will succeed, where you're going to, how your team is, where you're going to succeed, what the opportunity. Don't forget what you want when you pitch. Don't forget the opportunity.
Derek is just sitting here. He's working on his speech right now for any remaining time. Look at my watch. I'm going to say T-minus 15 seconds. Remember, we've got 8 minutes. Watch it on your clock. Help me count them down. 5 minutes, 3 minutes, 1 minute. Off the stage. 5,
4, 3, 2, 1, start.
Hello, thank you very much, Eric. I would like to use my 7 minutes actually as sort of break from blockchain. So this will be a little bit change. I hope it doesn't mean a rapid fire in my knees, so we'll see. So as you probably already know, all of you, is that APIs are really well recognized, well used, widely adopted technologies, widely used for exchange of data, integration, and so on. The idea is that now when the APIs are becoming like more mature, they are after the puberty, they finished like the maturity exam, they are reaching to the new phase. The idea is, I think, is that it's about time to make them like more standardized, organize them in a way that they are easy to consume, and forget about them and make them actually a consistent part of our system and stop discussing like, okay, we use API here, API there. Make it like a part of the protocol that we use and don't worry about it too much anymore. So I would like to touch on 2 topics related with standardization and best practices related with the development of the APIs as something that I think can be very useful, and I hope it brings you some value to the discussion. So the APIs adoption is growing very fast. In the just 2 years, the API calls, instead of this being quite old technology, the API calls, number of calls globally grew from 3 billion to over 30 billion in just 2 years. So there's been tenfold growth. The blockchain probably has bigger growth, but in this scale of numbers, it's much bigger also. So, however, the biggest use cases are still like strange. So, is it the pointer? Yeah. So, the most common case of using the APIs is where the people go for the business logic. They have to invoke some kind of function. They want something to be done. So then this is the most case where people go, okay, I will have some API that will do for me some kind of a logic. Other case that is not as popular, but also is the data transformation. So I have to transform the data, maybe from one format to the another. Maybe I need to change something in the structure. So I do some API that will help me with this. Or I will probably, in the other cases, use some ETL tools, implement custom software, whatever.
5 minutes.
The last case is the data access. And this is actually the part that is related with the openness. And this is also what I would like to touch, is that so far we are discussing a lot about the trust, but I think the APIs are in the heart of the openness of the data. And this is, I think, the part where these 2 topics I would like to touch are very helpful. So when you are integrating to exchange data over API, there are usually 2 problems. First is you need to learn about the model of the data. You need to know what are the objects there, what are the fields, what actually is the type of the data, what are the relationships between those objects that we are using. And the second is the infrastructure. So this is usually where it all goes. So there are 2 practices I would like to briefly talk about. First is called HATOAS. It's a horrible name. It's hypermedia as the engine of application state. Let's not mention this name again. However, it's basically a very useful tool for directing people on the API. And the second is OData. OData partially actually also incorporates HATOAS. However, I separate them because HATOAS actually can give you a little bit more in some areas, and OData is actually promising a little different part. So let's start with the OData. So how OData works is that you have an additional layer. This is like built on top of the API, where you have your regular API, when you can do all the web requests. You can get the data in form of I get the information about the products, I get the information about transactions, about the orders, about the quantities, and so on. And then, actually, the metadata is like a taxonomy for the API. So I no longer have to read the entire documentation to understand my API, to do some kind of models and so on. I can just automatically read the metadata and, like an XBRL taxonomy, just understand API automatically. And this software can immediately consume the data. It's as easy that there are even Excel components that can directly connect OData to the Excel. Other layer is querying. So it's like combination of taxonomy. You can think about combination of taxonomy and SQL. So now you can not only access the data in form of, I know how the data looks, but I know how to query it. I know how to filter it and so on. The next part is the H2S. It's a relation when you get the information about the object. It's a tool with which someone who provides you the data can guide you with the data to the further places. So now I give you information in this example, let's say. I'm giving the information about the account. And now, for you to learn, when you are getting this account, you can already learn. You don't need to know, okay, I need to know entire API. So this is the way where I get the account information. This is the place when I deposit the data. This is where I withdraw. This is when I transfer. No, I just need to get the information about the account. And account internally already has the other information to move further over the API. So this is like a GPS, you can call it. So this is the way for the API provider to guide the person who is consuming the API over the next places of the API. So what it all brings together. When you have everything together, you have very easy to read layer of the OData. This gives you possibility to directly connect to the data. I don't have the time to give you the demo of this. However, it's as easy as just connecting to the, I don't know, ORM type of things that you use in the regular software development, connecting to the database. Regular layer of the API, and using these hypermedia, you can direct people to different places. Let's say, for example, to achieve better security, basing on someone authentication and his rights, I can move him to actually completely separate environment when he is physically disconnected from other places. So this gives potentially even higher security. But I can also scale using this. So I can, for example, have very particular part of the API that will be scalable just for this particular use case. So all of this, if you want to get some more information, you can find under these links. I believe the slides will be available later. I would like to just encourage you to follow these practices, because I believe this is like the last step in the development of the API. And because when you will be integrating all other technologies, blockchains, big data, AIs, somewhere in the chain, some kind of API will appear, because you will need to integrate the data, systems, all of the other systems that you already have in place, and also other new things that we'll be introducing. So API will appear somewhere. And if you will follow these structure, these simple practices, you can spend less time on the APIs, and you can spend more time on the actual system.
Thank you very much. Let's hear it for our first speaker. Maria, get ready for your staging time. Okay, what do you think? Exciting stuff? Interesting stuff? You ready for another one?
Sorry for me leaving, but I have to go for a plane.
We understand. Our first two speakers are headed off to airplanes, so they will not know when we vote for them. Keep that in mind. No one will feel hurt when they're out of the room. Our second speaker, Maria, are you almost ready to go? Getting the mic in place. Okay, you got the microphone in place. Derek, you ready to hit the timer?
Yes, I am ready. It was interesting, though, Carol. Yes.
You good to go?
Yeah.
In 5, 4, 3, 2, 1. You're on for 7 minutes. Go.
Hi, I'm Maria Teresa. I'm a full stack developer. I'm working in Justy Global. And today I'm going to talk about digital identity and the problems that we have right now and how we can solve it with blockchain technology. So first, the meaning of identity is, for example, characteristics that define by a person, right? these definitions, I think that are the best definition to explain the meaning of identity. So for me, digital identity should be these definitions with in a digital world. So digital identity is so important in our life. We have a lot of digital identity. For example, in social media, everyone have a Facebook account. Or maybe in banks, when we're doing a transaction, we use our mobile phone, and the mobile phone has our digital identity. For example, at work, we send an email, and the email represents our digital identity in the work. So the problem is, who owns our identity? So the problem is that everyone except you. When you share the data doesn't belong to you. That's a problem. So I'm going to explain with 3 examples the problems of the digital identity. So when we are going to do an enrollment process, we complete a formulary with a lot of data. Maybe too much data for the process, too much data that the process will be need. So this is something like this. Another example is, for example, when we go to a nightclub. The doorman, sometimes, for example, me, I'm young, the doorman always asks for my identity, in Spain, the DNI. And the DNI shows where do you live, your parents' name, and he only needs the information if you are not a minor person. So that's a problem in the physical world and in the digital world. Another problem is when you share your data, you don't know where the data is stored. You are going to share the data, and the data is stored somewhere, and maybe it's like a lock in the bridge. It's always there, and you cannot delete it or even modify it. So that's a problem too. And finally, I don't know if everyone see Game of Thrones. This is Bravo City, and this character has an infinity face. We have a lot of digital identities, and the data of the digital identities is not correlated. You have Facebook, you have, for example, your bank account. You have the same data, and the data is not correlated. So that's a problem. So finally, what is the holy grail of the digital identity? Be the owner of your own identity. Everybody has your data, and you don't have it. So that's a problem. So now I'm going to talk about a solution that we have developed in UST Global that will be an open source project. Sorry. And this application will allow the user to decide what data shares and what not. And he will be the owner of its identity. For example, it will be also revoke the data for an entities. If I want an account in the bank and I want to go to another bank, maybe this bank will have this identity and I don't want it. So with this application, I will revoke the data to this bank. Well, I'm going to talk this, but I think that I have not enough time. But the essence is that you have the identity and you only share the attributes to the entities, to the other entities. So these entities maybe will be validate this data, or maybe will be asked for an enrollment process. So now I'm going to show a video. This is a lovely music.
1 minute?
No. So this is the demo. We are going to create an identity, and we are going to provide an identity number that is our identifier, and a caller that will be the person who can see the data of the identity. In this case, I will be James 1, and I'm going to write in the formulary or my data. It's not necessary to write all the data, because you only say that you want. So you must say if you are dead or alive, because
Thank you very much for your 7 minutes. Maria also has to be leaving for the airport right now. Thank you very much, Marcel. Are you ready to be up? You will be up in 30 seconds to 45 seconds for your session. In the next of our rapid fire sessions. Identity, huge deal. In the United States, they established a new governmental private thing called the ID ecosystem, so you could give out just the attributes you need while meeting everybody's needs. You get the right information, but you only give away the information you need. Very, very important. Mark,
this is the largest display you can make?
Yeah, because it's here.
That's okay.
Mark,
Hello.
are you ready to go? We got our timer going in 5, 4, 3, 2, 1. Mark, 7 minutes.
Good afternoon. I'm going to share some ideas from a project we did for the gentleman you saw yesterday via Skype, Peter van den Hul of DG FISMA. It's a working piece of software based on the blockchain. And Henning, who's now running away, was part of the development as well. Just show you the disclaimer, so the Commission is also happy with that. Now, what's the problem? The problem is that in 2008, we saw that many enterprises are actually in the financial services industry. They're flying blind without instrumentation. Now, there are ideas within the Commission, and they're working very hard on modernization. Peter spoke about his FDS, Financial Data Standardization project. There are two sub-projects. The first one is semantics. How do you fix semantics? We've been talking about semantics quite a bit. The second is, well, you know, centralized. You could put it in a database. However, that's not always appreciated by the stakeholders. So what was the solution? First of all, this is a huge space. How do you eat an elephant? By slicing. So we limited ourselves. We refer to it now, this is the FISMA blockchain demonstrator, but it's actually in full the FISMA over-the-counter derivatives trading reporting blockchain demonstrator. That's what it's doing, nothing beyond that scope. How did we address the sub-problems? Well, there is no agreed semantics. We found a great source of semantics called the Actus project. Check it out on the internet if you've never seen it. And if you don't like a centralized, we go for decentralized, so we just use Ethereum smart contracts. Actus, you find the detailed, let's say, semantic and algorithmic definitions of the majority of the let's say, the financial agreements, and derivatives is one of these
5 minutes,
which fall underneath it. To put us all on the same page regarding blockchain, I mean, I'm sure you know, on the left you see a blockchain with 2 blocks. There are candidates, there is a consensus, and we end up with 1 more block. So smart contracts, we wrote smart contracts that embed OTC derivatives. They have this state and logic. And we have then set up a demonstrator where you have a series of nodes connected, the yellow and the red dots. And using the Actus semantics, Alice and Bob, they trade with Eve, and there is Romeo who can then fire off compliance reports. So there are 3 stories in the demonstrator, of which I'm going to share one with you. Alice and Bob conclude a bond contract, and we create a digital doppelganger, and then there is the narrator which simulates the time. And Romeo generates a regulatory report, a COREP report. Now, all data is available on the chain according to agreed semantics. All the calculations can thus be performed in real time, and the report is available immediate, while it used to take weeks or longer than that. How does the user interface look like? Well, this is just a Meteor web server. You create a new contract. Initially, all these nodes disagree. There is no consensus. So this can be visualized in this way. Here we take some technical parameters. When the consensus protocol has run, they're all in sync. They all have consensus, and that can be, say, measured or expressed in this way. So then you will have the new contract between Alice and Bob on the chain. You can take any node. It will have the same copy of that contract. And then you can fire off the report that you want using the information which is on-chain available in the blockchain. That's essentially what we did in a nutshell. I think I have one last slide. There's a movie. The movie is, I think, like 10 or 15 minutes.
3 minutes.
What?
3 minutes.
Well, okay, I'm not going to start the movie now because the movie will take us too long. But the movie builds up, tells you the 3 stories, tells you what we try to do. And there is an article online there published explaining what this project has been doing. And with that, I think I rest my case. Thank you.
If you want, you can take questions. You can give Maria the rest of your 2 minutes, whatever you want.
Yeah, no.
Sing a song, tell a joke.
I'm not
2
good
minutes
in
and 30
those.
seconds.
You want to sing? Questions? No questions.
Is it commercially running, or is it a prototype?
It's an in-house prototype for the commission.
Which platform are you running on the...
Private Ethereum, Solidity contracts. Okay. Yeah. What framework do you refer to?
When you use I understand that's OTC, right?
This is?
You grab the data from OTC, right? Derivatives, right?
Yeah.
So the system that was doing that before you introduced this one on blockchain, was it completely decommissioned? Why do you, what do you?
Wait, what is in place stays in place. This is an experiment. It's a demonstrator. It lacks a lot of features to make it production ripe. If the Commission finds consensus internally, politically, and funding, I don't see a reason why you could not build this and put this into production. But that was not the purpose of the project. This was a short-time proof of concept, you could say. No, it's a sandbox solution. Yeah, but we are working on a new project which is going to be exposed for 1 year then with a selection of users.
You may use up to 1 more minute.
Oh, thank you. You're too kind. Did I answer your question? Okay, thank you. There are no questions? So.
But then the dancing starts.
Either I'm a brilliant speaker or you are all very, very, very smart listeners. I guess it's the latter.
Okay, he's going to start complimenting you. That's the way to do it. All right, excellent. And for the last of our part 1, Simon, will you get staged?
With Mark, it might be upstaged, but with Simon, Simon's going to get staged.
Do I have to put this here? Sorry.
He's connected?
Connected, yeah.
He's on the air.
Should I put it somewhere?
Yeah, in the pocket.
Slides are ready. And 3, 2, 1, your 7 minutes begin.
Hi, my name is Simon Olsen. I'm working in product innovation for a company called Lifecycle, which is trying to build the future of markets. You know, the world currently has the following problem. We are full of problems which urgently need solution. The environmental damage, poverty, there's a complete lack of investment. And at the same time, interest rates on 30 years are abysmally low. You have unemployment, you have a lack of credit, a lack of opportunities for the many. In the Middle East, you saw it first, then you saw it in Europe and in the US. This is a problem that requires a solution. It's a problem that the money is not going from there where it is person who gets no interest rate, to there where it's needed to solve problems. We are trying to build an exchange, a global exchange, without any fees, which is accessible to everyone, wherever he may come from, to the same terms, where everyone has the same market access. We're trying to build a fully regulated exchange for any kind of financial asset on the blockchain. We've built an architecture of a semi-decentralized exchange. I encourage you, didn't use a presentation on purpose. I encourage you to look on your phone. We have an app, you can download it, and you can use it immediately. We have 30,000 users. We have created a framework several frameworks for securities, products which are considered a security. There's a forward on the run for underlying shares, together with in dialogue with the Swiss regulator. We are creating regulated units in Switzerland, in Singapore, in the US. We will become an issuing house in Switzerland by first quarter 2018. Our company is fully open source. We want to partner with everyone. This is a project, not so much a company, but rather a project, a movement to make the world better. What are the risks? Why are we going? What are the risks? There's many risks, and we're fully aware of it. We're aware of it that this can fail on any day. That there are millions of obstacles. In a way, we don't believe in miracles. We count on them. We use it both for B2C or B2B projects. Our team is currently 100 people. We're constantly looking for people to join us as consultants, as partners, who think with us, who want to work with us. I hope I could convince you that what we are doing is important and that we have a chance of succeeding. Do you have any questions?
Hey, Simon, you've got 3 minutes left. You can take questions, tell stories, jokes, little dance, little song, whatever you want.
Please, Ignacio.
Ignacio, build me out. I understand that this is an open collaboration, a movement that sounds great, but how in practice is organized?
We are a company incorporated in Zug. We have 100 employees or consultants who work from about 100, who are living all over the world. We have employees in Russia, in Perm. We have employees in Tehran. We have someone in Ariel, an Israeli settlement. We do not have any prejudices. We all think alike. We all share the same vision, the same ethics, and the same mission. We have people in Brazil, in the US, in Asia. There is a regulated part, so we see that you have these regulated entities, which in Switzerland or which are regulated, but we have an innovation approach across the company. And we have an accelerator. All our solution, you can go to GitHub, we have 3 million lines of code. So our only principle with collaboration is open source, no monopolies, and yeah, so that's kind of, is this good? And we have 4,000 investors. We have a coin, which is our share, which is a derivative for the underlying share, and we have a community on Slack, on Telegram, and yeah, I think that's that one. Michael?
What kind of equivalents or financial instruments can
1
you
minute.
trade on this stock exchange?
So currently, you know, we are only regulated in very bad place, Vanuatu. And, you know, so there, you know, I don't know the regulator. It's very difficult to it's far away. It's difficult to talk with them. So we are setting up an issuing house in Switzerland, so it will be for bonds and the equities, for any kind of financial instrument. Or also what you can do, which works well, is kind of rights of storage. For example, you have gold commodities stored, so you can trade commodities which are stored, you know, like in storage, which is a big advantage, because the problem is if you are trading futures at COMEX and you really have a crisis and everybody wants the gold, it's nowhere, you will never get it. So that's, in principle, you can have any kind of financial instrument. The key is just, in this exchange, the key is that it's a real underlying asset. We have rules of exchange. I'm happy to share it with all of you.
Okay, thank you very much. And we're at the end of our first section. Let's quick give a hand to all of our speakers. And let me turn to our esteemed panel, our my Eurofilings and the organizers. Do we have any quick words? Do you want to influence our voters before they vote? Which was their favorite session for our first half?
I would say that Carol mentioned 2 words, open data. I didn't mention trusted nor ecosystems, but
okay.
I think that's good.
You're not going to hold that against them, though, but you'll bring it up. Any other quick from our organizers? If not, I would ask you, but you do have a little stake in our vote here, since Bragg is here. Okay, so we have our first 4. We've got Carol, who spoke about next generation APIs. APIs really important. Blockchain will not exist in a silo. It's going to be looking into all sorts of systems, external data, all sorts of things. API is very important. We had Maria, who spoke to us about identity. Boy, identity is a big deal, whether it's trying to preserve your identity, making sure people don't find out about you what you don't want them to know about, while making sure that people who rely on identity can find it. We had Mark, and Mark spoke about the demonstrator that was prepared for DG FISMA. Lots of great questions there. And finally, Simon spoke about the exchange work. So let's begin in that order. Let's give some applause first for Carol and APIs. Let me hear your applause. Next, maybe a little bit of the sorry for what Eric did for her vote. Let's hear from Maria. Let's hear it from Mark. And finally, let's hear it for Simon. To this first group of speakers, thank you very much. You're dismissed back to the audience, to airplanes, or wherever you're going. And our next group will Jose, Jarko, and Henning please come to the stage. So thank you. Go to the audience. Make room for our next group of 3.
Thank you.
So we're going to be hearing about some very exciting things. We're going to be hearing about AI. Like I say, do not go to Google and search for easy steps to AI. I learned that that's a bad thing. I learned how to make baby cows. Bad thing. Jarko, and I have to recuse myself. Jarko's going to be speaking about working with XBRL GL. That's my baby. Very excited to be hearing about what's going on there. Henning is going to be talking about research and production in the blockchain environment. Going to be a very exciting time as well. So Jose is going to be our first person up, getting wired up and ready to go. How you doing, guys? Keeping enough energy here? Second to last session. We're staying on time, maybe to the dismay of some.
It's an interesting type of time.
We're learning. Excellent. I see 2 people. Who are we missing? Jose, Jarko?
This will be from the video.
Okay. Oh, okay.
Somebody
Very
online,
good.
yeah.
Okay, are you ready to go? Then in 5, 4, 3, 2, 1, you got 7 minutes. Go.
Hi everyone, my name is Jose. Can I get a microphone?
Where's the microphone? There is
Use my microphone. I can emote.
Hi, I'm Jose Gomez. I'm the CEO of Centimer Technologies. We are an artificial intelligence company based in Madrid. We work with banks, with utilities, with insurance companies, with financial services in Europe and in Asia. And we provide services for artificial intelligence, new ways to communicate to users, and to get relevant data to make decisions. So why do we exist? Basically, we see there is a huge problem in the financial industry, telecom, insurance, almost any of this kind of business. It's complex and boring for the user. They hate it. They don't like the process. There was a survey saying that 3/4 of millennials prefer to go to the dentist than going to the bank. And it's pretty difficult to scale. If you are trying to sell financial products, you need an army of guys doing that. And when you want to do that at a massive level, it gets really expensive to escalate and to coordinate. Okay, so the challenge is how can we make the process of buying a product, an insurance product, personalized, simple, and extremely scalable, that we can almost do it automatically. So we, at Centimer, yeah, so okay, it's a pretty cool video. That doesn't work. Anyways, so basically we are working with them saying, is there an intelligent way that we can use artificial intelligence to determine which are the true needs and preferences of the user, adapting to what he tells us with his own words to determine which is the right product to recommend.
5 minutes.
Yeah, thanks. And adapt to what he might want and anticipate. This means if the guy is pushing like crazy, so you say, hey, this guy is not serious. If the guy gives you contradictory information, it's okay. Our artificial intelligence will determine he's saying that he's risk averse, but at the same time he's going for more aggressive strategy. Make extra questions. We are yeah. Oh, now it's working. So what is behind this? We are analyzing every single movement of the person with the bot. So if we analyze what he says, how long does it take compared to people like them, which is the type of business segment this user belongs to. We on real time also access other data sources apart from the customer system. We go to Facebook, to Twitter, we check everything, and in real time we can say, how good of a potential customer is this? How sure he is of what he's doing? Is he engaged into this transaction? And make active actuations in order to avoid him to abandon or not to buy. Also, so what is behind this? We are working with all these companies, and I will tell you that after several years, the key here is the natural language. I mean, if you have the ability to understand what people say, there's a new universe of data you can analyze. How he's feeling. Is he having a...
3 minutes.
Is he having... Can we say that he knows what he's doing? Because as a provider of financial services, you will run the standard questionnaire, but if you are providing a bad advice, this customer is not going to be happy. With this kind of tools, you can analyze whether he's really understanding what he's doing. We are applying this to a lot of regulatory and legal stuff. For example, in banks, we use this kind of tools to receive questions from the branches, and the robot will determine what is the right answer. So you can save, I think it's around 65 to 70% of lawyers' cost answering questions from the branches, just simply due to this ability to understand what people want and provide the right answer. Also, the systems learns over time. They learn how the customer feels, what to say, what to respond, what are the best offers, how to customize the tone, the way you talk to the person through the bot, in order to provide him an excellent experience and making sure that he is getting the right financial product. And this can be, and we think that currently no company is willing to spend months or hundreds of thousands or millions of dollars doing this. We believe that artificial intelligence should be intelligent enough not to require months of work. So having a system that can provide you quick results in a month, that you don't have to involve half of your company in order to get some meaningful results, is extremely important. And I think that's it. I will be happy to take some questions. Yeah.
You're analyzing a lot of customer data, right? The data that the customer provides to the financial institution.
Yep.
So first of all, does the customer give consent to analyze the data?
Yep.
1 minute.
Second question, what if the conversation with a particular customer is very, very limited? For instance, I typically shout at my partner. And I just don't really give them a lot of data to feed on.
Well, basically, there are two sets of data. It's pre-engagement, so any data I have on the CRM of the bank, I will use it. And second is in real time. So the way you answer to the questions, what you answer, how long does it take to you? If you make questions, how many questions, and what was your feeling about it, determined from the natural language. That provides me a lot of information on what to do next.
Is it from speech or from written?
Both.
7, 6, 5, 4, 3.
Thank you.
Jarko is next. We want to save you for.
Okay, thank you.
Okay, I want to let you know that we worked really hard here. Jarko is coming to us via video. He's been told he has 7 minutes. Let's see if on the pre-recorded video we can.
Buenas tardes.
Say it again.
Buenas tardes.
Okay, Jarko, are you ready? 5, 4, 3, 2, 1. You got 7 minutes.
Thank you for giving me the opportunity to participate in the conference for trusted open data ecosystems. My name is Jaakko Jevert. I'm a Finnish S&P auditor practicing in my own audit firm. Today we are going to spend the next 7 minutes with the problem of verifying bits. The auditor is in a role of assuring data trusted. And an auditor is always an outsider. It doesn't matter if the documents are in the custody of an organization or if the documents are in the custody of an algorithm like blockchain. Traditionally, verifying documents was literally handling papers. Today, documents are bits. And verifying bits is a very great challenge for auditors. The bits may be easily corrupted. I still don't know any other way of verifying a document except asking an external confirmation. This is slow when it's done manually, but with the help of automation we can do it effectively and in large scale. First, we should define in a standard document 2 fields as pointers to the participants. With a pointer, I mean an internet address to the participants' information system, where you can leave a query of the data to be confirmed. Second, we should have the software to handle this process. Instead of making 1-by-1 letters of confirmation, a computer can do it fast and in a large scale. The auditor can load data to be confirmed from the company to be audited into his own program. Then he creates a table consisting of the pointer to the counterpart of the document. That is, the counterpart's gate address. Information of the document, such as identification fields like invoice number, product information, amounts and sums, and the last column of the table is for verification, and that is yet empty. He sends the table rows according to the pointer addresses in the internet to the different counterparts and their gates. At the gate, there is a system that can receive data from the auditor. The gate calculates an answer which is confirmed, busted, or no such item. The gate would not give any extra information than what has been asked. I hope it will not be difficult to stop phishing. The smallest amount of information would be probably the pointer, identification like invoice number, and a checksum. And the answer would be the correct checksum or no such item. The firewall should take care that no other information could be taken from the receiver's information system. The gate sends back the table with the verification column filled. So, and how much do we need internet communication? The communication happens between the company that will be audited and the auditor and the transaction counterpart of the company. The companies have an obligation to keep the records. When transactions are made at arm's length, a counterpart's confirmation is generally considered to be trusted. The communication is only between the three. As blockchain needs communication between all servers in the chain, there will be much more communication compared to the model just spoken of. In Europe alone, there are some 10 billion e-invoices annually. If all these documents were kept in a blockchain, the amount of communication between the blockchain servers would be on another level compared to the using pointer between participants. According to some sources, the Bitcoin has more servers than Google, and Google as an electricity user compared to states is somewhere like number 45. So we should also look for solutions that are less energy intense than blockchain. What do we need to do this? We need a definition of two fields in standard documents, like XBRL global ledger or e-invoice. Definition of two fields as pointers to the participant's internet data system. And the second, of course, we need programs to deal with this kind of communication. The benefits: large-scale confirmation is possible. Complete materials can be confirmed instead of samples or statistical assurance, which is usual in auditing. This kind of massive confirmation process could be interesting also for any other party focused on trusted data. So thank you for your time. We have some short time for questions, and I hope the Skype connection will function so that we can continue this in Skype. Thank you.
There's 20 seconds left to the session.
Any questions?
Are we actually on a Skype connection at this point?
We have no questions.
Okay, no Skype. So Henning is going to get staged here. Henning will be giving us the clarion call on research and production in a blockchain environment. So again, the last session is what I spend my time working on is trying to get it so that XBRL Geo and other data standards that semantic can be referred to or included within the blockchain so that all the things that you just heard about and much more can take place. Henning, are you ready to go? And he's testing and there were some problems with that. Let me give you this. You are our last speaker, so we want to make sure we all hear.
Hello?
Don't need a penalty. make sure that you're on the air.
Nice.
And Henning, you're on in 5, 4, 3, 2, 1, improv.
Hey, hello. All right. I would like to take the chance to talk a little bit about my company, but also use it to be a little bit philosophical. Maybe that's a good time now in the frame of the last 2 days. First, about my company, if you progress to the next slide. So the reason it exists is basically the real drivers of the blockchain space are people who seldomly find their ways to this kind of conference or work for the European Commission. And those are the crypto nerds who actually started this all off. Blockchain has a long history that's often forgotten. It started in the 80s, actually, with people who understood that the way that governments and corporations started to equip themselves with computers would be able to trace us and every single move that we do in our economic lives and create profiles from that. And it wasn't hard to imagine that this would lead to surveillance systems, and this would have a feedback then on the behavior of people, where you wouldn't do certain things because you know you're being traced. And this is, of course, to people who have a strong sensitivity for freedom and for liberty, something that's called stifling. People will, in effect, start self-censoring themselves. And we are all a little bit in that future now that back then people hoped to avert, where we know that there's megabytes of data about us stored the world over, right? We've totally gotten used to that. We don't even know where it is stored. We have no idea who is controlling it, who could do what with it. And we've basically come to terms with the fact that large elements in our lives are governed by pattern matching, right? So the guys that are actually today working on blockchain and who are actually setting the agenda in a certain way because they are still at the forefront of the research. They still have the best understanding of what's actually possible. It's not the corporations, even though we have a lot of, some of it is vaporware, to be honest, a lot of marketing that's out there, but only a few people actually understand where this journey might lead, and they are not a lot, actually. But they also have very strong ideals that are often very incompatible with making blockchain useful for business, which is I find personally very interesting. And they're also, by and large, pretty rich, meanwhile, which is a nice side effect of those cryptocurrencies. So it's hard to get to employ them or to get their advice on stuff that is important. So I'm motivated by actually trying to leverage blockchain for stuff that is something that we could all benefit from. And this is why I've build a small company to be able to advise, for example, the European Commission, for which you have to set up a certain official framework. And by this, bring in the advice of the original hardcore of blockchain to for example, points in the European Commission that could actually make a difference in using this technology for future regulation. Talking about regulation and business rules and applications in the economy, I would like to end this with a thought about what we actually do. We all know that work is becoming scarce. The definition of people by their employment is becoming something that's more and more difficult to sustain because more and more people are going to get out of work. In the moment we're talking about replacing truck drivers by artificial intelligence, basically. There's huge amounts of truck drivers in the world. And I hear very little about what all these people are going to do in the future. But you could also take a more extreme view, and that is that we might actually be post-scarcity already, which means, like, theoretically, very few of us would have to work at all. And if you look at who's actually building houses nowadays, who's actually farming, who's actually even building cars, it's very few people. All the rest of us, and regulators are very much at the forefront of that, and people who create tools for regulators, even more on a more abstract level, in the end we're all pretty much busy with organizing ourselves better to organize other people better to then make them able to better organize other people. And blockchain, of course, can be used for that. and then we add another layer on top of it, and then all the organization may get more efficient and more transparent and all of that. But actually, baked into the fabric of blockchain is a very libertarian, is a very self-empowering principle. And I think in that, this technology, and all its unwieldiness also, is probably offering a chance to make things qualitatively better, to go back and look at what really serves humans. That's it.
Got a minute 30.
Anybody having any questions, or would anybody like to take the mic and add something to that? That laughter sounded like it. Yeah, sure.
I'm intrigued to learn more about what your company is doing, or what you want to do, and what your plan is. And
All right, so honestly, there are not too big plans. How many seconds?
1 minute. Well,
1 minute.
60. In Canada, it's 57.
All right. So as I said, I mean, this is really like I founded this company to be able to work and to advise the European Commission. And I am personally, I'm really interested to make things possible and to try to get the real technical advice somehow distilled in a way that experts in a certain domain are able to work with it to create great stuff from that. And this is a very ad hoc orientation, if you want. And I believe that basically a lot of what's going on in the blockchain space is really ill-informed. There are a lot of people trying to do stuff with blockchain that do not really understand the domains that they want to change very well. But there's also huge misunderstandings and marketing and vaporware in other domains that do not understand blockchain very well. So that is really what I'm trying to accomplish, to bring those people together. Thank you.
Sorry about your ear there, Derek. All right, for our second half, we had three great sessions. Jose spoke to us about sentiment analysis, natural language, real-time personalization. Jaco came in at 6 minutes and 40 seconds, wonderfully well, to speak about automated auditing using XBRL GL and e-invoicing, and Henning spoke, again, delivering his clarion call, research production from cypherpunks to corporate suits. Where's this all going? So again, let's do our second half vote. But before we do that, again, Ignacio, Derek, do we have anything that you'd like to say to the group to do some influencing for our second half vote?
I'm looking forward to the Clarion coin rate.
Thanks.
Okay, so let's have the vote first for Jose Sentimer. For Jaco and auditing with a data standard. And finally, Henning, and where this is all going and how we get there. Again, 1 minute for our judges to confirm. We're going to have the final votes. Okay. What do you think won the second half? What do you say? Okay. And who do you think won the second half there on that one? You go. Okay. So here's what the judges say. The first half winner was Maria with the no mercy vote. Henning won part 2, and so now Maria versus Henning. How many want to vote for Maria? Hey, woo! How many want to vote for Henning? Judges, was it Henning?
You didn't listen. You made noise.
All right, great. Hey, 7 great sessions. 1 hour on the dot. Thank you, everybody, for your participation. We have one more session before we finalize. To our speakers, thank you very much. To those who facilitated, thank you very much. To everyone who...
Thank you, Eric. Thank you. right on time.
So, according with the agenda, we have now 1 point. That is related to you. Let me check. Okay. So as you know, this event is part of activities that started in 2005. Why? Because in 2005, the Committee of European Banking Supervisors, that at such a time was, the chairman was the general director of supervision in the Bank of Spain, received a suggestion to harmonize the European formats. Why? Because Walter Hanser, in the Bank for International Settlements, make a speech about the use of XML derivatives as XBRL, potentially for financial statements. The governor of the Bank of Spain attended such speech, but the degree of the governor of the Bank of Spain, Jaime Caruana, that currently is the general director of the BIS, was engineer in telecommunications. And he immediately captured the power of structured information for banking reporting. Then the governor asked to José María Roldán, the General Director of Supervision, please take care of that. And José María Roldán was not an IT expert, but was a General Director, and his boss said, investigate, and he investigated, and by chance he was nominated as first chairman of the Committee of European Banking Supervisors. Okay, in turn, the General Director of Supervision say, okay, this is a topic for IT, and asked to the Director of IT, Federico Flores. And Federico Flores was in a hierarchical level below the General Directors. And Federico Flores say, jawohl, and immediately start to work. And, but a lot of people was involved in the IT department in serious things. But there was only one that was not involved in very serious things. I say, Ignacio, you have to work in XBRL. And I say, I have the standardization the first time when you should be involved in XBRL. I say, XBRL what? But no problem, as the governor ordered to the Director General ordered to the Director of Department, and the Director of Department ordered to me, and in this moment I have no people below. I was the representative of the IT department in international groups. I was nobody. I say, okay, no problem. And I asked him, okay, and about resources, money, and so on? No. We are modern. This kind of resources is for bureaucrats and civil servants. Okay, no problem, easy. Then I started to think how to create a regulatory framework with this amount of resources. And they say, easy, the solution is to obtain resources for free. It's evident. Then I organize a call for everybody, including Walter Hanser, including Charlie Hoffman, and including everybody in the first European Banking Supervisor Workshop for 2 weeks. And suddenly a lot of people can hear. I say, easy, easy. Then with all, after 2 weeks in Madrid, we review the possibilities and so on, we started to work and say, what is the way? The world is full of resources, it's full of people that have enough time to work in this kind of events. So, after this first Eurofiling workshop, we organize the second, the third. This is the 24th. And the way from since the very beginning to now is exactly the same. Put the people to collaborate, to work together, and so on. Obviously, at the end of the day, you need to have more structured approach. But basically, this is the work that the way to work that we are doing. In addition to the workshops, we organized, for instance, a portal and a number of web pages with a lot of information and topics and so on. So we leverage in the power of the internet as a collaboration environment. But and also we pay. In something that is very, very important and is not so expensive, recognition. And for us, we are extremely honored to recognize the work, mostly for free, for a lot of colleagues and friends and so on. And Derek commented, okay, the Eurofiling community is wonderful, because at the end, Derek became the chair of the Eurofiling community, and considered, well, but why not to put some kind of formal structure? And now, Derek, it's your turn to explain the last steps.
So indeed, we had the feeling the last couple of years that Eurofiling needs a legal structure to be able to represent itself, to be invited in some formal meetings. Myself, I was, for example, at the European Commission and the standardization body, SEN, and I was in a meeting room last year, and they asked me who are you representing. I said Eurofiling. And who is Eurofiling? And then I had to start a complex explanation that didn't make any sense. So it's a virtual community gathering every once in a while, blah, 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 since 10 years or 12 years. They say, okay, sorry, but we cannot mention you at all in the minutes of the meeting because you don't represent anything at all. So that's why we said, okay, let's set up a simple legal structure, the most lean and mean format that we can find. We came out in the Kingdom of Belgium, beautiful Kingdom of Belgium. We have a foundation, structure for a private foundation, which requires a zero budget. So you don't need to invest the capital, etc. So the only thing you do, you import the capital that you have in the foundation. And so we did it. We did not react. We said, okay, we import the patrimonium of Eurofiling, which is residing at the website, the portal. So I just showed, so this is the patrimonium. It contains a zillion documents which get consulted by many people across Europe and even across the world. So many people just come and visit the site and to find some documents. And that's in fact the patrimonium. It has been built by the efforts of many of you. Many of you also in the newswire are listening. Hundreds of thousands of people are now watching online. So all of them have been contributing all these years, not in the least, of course, Ignacio, who has worked for all these years, despite the fact he retired from the foundation from Eurofiling 2 years ago. He's back more than ever, so thank you, Ignacio, for all that. So to support all these initiatives and all these efforts and to recognize also the effort, I found it very important that we make the step and to set up a legal structure. So that's what we did this summer. We found Luc Dufresne, Honorary Secretary General of the National Bank of Belgium, willing to be the third founding member, because for a foundation you need 3 people that set up the board of the foundation. So we had Luc Dufresne, who is also a very known person to many of you from the National Bank of Belgium, supporting the idea and co-found the foundation. For reference, Luc has also been the founder of XBRL Belgium, has also been one of the founders of XBRL Europe. So he has a long history of also doing voluntary work in the area that we are all working in. So what we did, we set up the foundation, and then we discussed a couple of weeks ago, we had a meeting, the first board meeting, and we said, okay, let's open up the board for additional people, because maybe it can only be better to have more people in the board. So we opened with a call for participants to all the trustees and all the people that support the foundation. And we got a number of candidates that Ignacio now will present. Yes.
So, I am very proud to translate the nomination of the board to a person from the north of Europe, living currently around the world, my friend Liz Watson. Please. Some word for the public. Remember that this will be recorded and put on internet.
Well, I think, first of all, that the work that has been done, the foundation that is already there, is just amazing. I mean, the things that you have pulled off over the years, I've been an admirer for a long time. But we also have a lot of challenges coming forward to be able to expand what we do. So I'm so honored to be here. I can't even tell you, there's very few times I get goosebumps on things, and that's what I have today. Not am I just honored, but I'm also going to take this very seriously and take a very active role and contribute to the good foundation that's already there. So I'm just very thankful to both of you.
So the next one is other long-term collaborator in the Eurofiling collaborative framework. Is well known for a lot of people in this room. Is Michal Pichowski. Michal, please.
Simply speaking, it's an honor, and I think the most important thing is the group of people that basically works together here. And I think mostly Ignacio is able to scoop people of the same character who just contribute without too much preconception, convictions, or interests, and just work on something. Technologies change, standards change, but the people are, I think, the most important. So thank you very much. It's an honor.
Okay, the other persons that has been nominated, unfortunately, are not physically with us, but by sure they want to be, but the life is the life, and we work in internet. Are Carla McKenna, please. Carla is a legend in the international standardization. Is working a lot, knowing a lot, and ready to work and to collaborate with others. This is basically the idea of us, the new member of the board, Michal Pichowski, comment, to work together. The last but not the least is another person that demonstrates his capacity in organization in Europe. Because Scarla is USA, as my grandson, my youngest grandson. The last but not the least is Mark Hemmerling, please. Mark is working in the Banking Association of Luxembourg and serves for many years and extremely well to the board, as chair of the board of XBRL Europe. As we are in Europe and we are collaborating a lot with our colleagues in XBRL Europe, even I am a board member I am member of the executive board of XBRL Europe, so we work all together. We have events like the Eurofiling XBRL Week, and someone that knows perfectly what are doing in both sides, in the regulator, in the banks, in the XBRL Europe, in whatever is Luc Hemmerling, and for such a reason has been nominated. Obviously, we have a long list of names, but for practical reasons, we decide to put only 7, because if not, the situation will be very difficult to coordinate among us. Are, as we say in Spain, all that are in the board are, but not all that are in the board. Okay, and that's all from our part of the new members in the Eurofiling Foundation. I think that Professor Javier and Michal Pichowski may formally close the TODE 2007. Thank you.
Okay. Good afternoon, all of you, dear representatives of Eurofiling, professors, keynote speakers, and panelists. Good afternoon, all of you. I want to say some closing words on behalf of Íñigo Navarro, the Dean of our Faculty of Law. I have been asked to close this year's session and edition of the TODE, the Trusted Open Data Ecosystems Conference. I'd like to remember, very briefly, the 3 essential values of Comillas, the name of this university. First, justicia, which means sum cuique tribure, what in Roman, Latin, Old Latin, Roman language means give each one what corresponds to him. Secondly, we might speak a lot about humanitas. Some of you have spoken about that, and the predominance of this value in this university is always there, and we have spoken in the different speeches and presentations a lot about the need of man to be over the machine and so on, particularly when we spoke about blockchain devices. And third, utilitas. We form here excellent professionals, and I think this is a unique opportunity to do so. Our FinTech Law Comillas Severis Observatory and its members, thank you all for coming here. We have been honored to host this year the Eurofiling event, and you have all definitely contributed to the scientific and professional development of our Center of Law Innovation. A fundamental piece of that Center of Law Innovation is this blockchain laboratory that we are actually trying to develop all together. And we have this laboratory, this new blockchain laboratory, at your your thorough disposal. We have limited resources, but we want to share it with all of you. And I hope that the considerations and premises that have been posed here in the fields of RegTech, RegTackle, and DataSphere for the 2030 horizon have been fruitful for all of you in form of speeches, presentation, or just personal thinkings. I would like to thank particularly the organizational efforts of Ignacio, Michal, Derek, Eric, Liv, and everyone. Also Javier, who I don't see here by now. And all the colleagues and experts that have been sharing with us this time physically or virtually attending Streamline all over the world. And you have all contributed for the regulatory development within this field. And last, I just want to declare formally close this conference. Thank you again, and hope you still enjoy your post-conference activities. Thank you very much.
Thank you. If you visit the social agenda, we have tonight dinner, farewell dinner, plus night drinks for the people so courageous to go for drinking in night in Madrid. And tomorrow morning a visit, walking visit, and you can find in the website in the agenda, or also in the papers we have here. Thank you.
And for those of you who know, today some of us celebrate the so-called Names Day. So all of you are invited for a drink for all the intellectual anarchists, libertarians, and dreamers in the room in the afternoon. So please be welcome. Thank you.
No, it's me. It's really in depth with you.
Once again, so very much thankful for the hosting.
Or the blockchain lab inside the FinTech Observatory. You just have to have applications, or you stay for the sociology? No, flying back home. You're flying back home. I'm driving, not flying, but driving back home. Just driving. Very good.
Raju, dziękuję Ci bardzo.
Thanks for having me, and congratulations on all your
It's serving role, so I serve.
Yeah. We all do.
I suppose also Belgian.
I didn't
see that we had
filing up such a long track.
I was just shocked that after without information, we had a very senior officer looking at all the stuff. I know her well, Olga Petrenko. She's a senior officer for market infrastructure, but she's speaker at Cyprus conferences and so on. She just joined in and put the